Hello everyone, I'm Monika Bhushan and today we are starting lecture number 8 of linear algebra. In today's class we are going to see what is the rank of a matrix. Okay, so rank is very useful term in our matrix theory. Before jumping to find the rank of a matrix, we will little bit put some time to understand that what is actually the rank of a matrix and why we need to find the rank of the matrix. We know that matrix is an array of numbers. Okay, fine. If I give you one simple example of matrix, this is suppose 1, 2, 3. Then if I'll write down here 2, 4, 6. Okay. Now this is one matrix. Fine. This is what? This is rows are 2 and the columns are 3. So 2 cross 3 is the dimension of this matrix. Okay. What is actually the purpose of having rows and what is the purpose of having columns? So rows and columns should contain the unique information. Okay. This contains the data 1, 2, 3 and the second row contains 2, 4, 6. If we will analyze these rows, then we will come to know that the second row is what? The second row is just 2 into row number 1. In row number 1, if we will multiply 2, right, then we will get the row number 2. That means what I am saying, we have seen the elementary row operations, right? So as per that rule, if we will be writing down 2 into R1, it is going to give me what is my R2. Okay, that means 1 into 2 is 2, 2 into 2 is 4 and 3 into 2 is 6. Okay, so the matrix contains 2 rows, that is for sure. But whether these rows are unique, the information contained by row number 1 and the information contained by row number 2, are they same or they are different? Basically, rank says us that the matrix should contain distinct rows, okay, or the unique rows. That means if the same information I am going to get by row number 2, then what is the use of this row number 2? Okay, row number 2 can be made by row number 1. Okay, and this rank does not allow us. What we have written that can be made. Okay, the same thing, if little technical way we will talk, row number 2 is linearly dependent on row number 1. So what is linearly dependency? So linear means what? If I'm going to multiply a row by a constant, okay, so the constant can be positive, negative, fractional, anything. Linear is multiplying by a constant, okay. And what is this dependent? It means that one row is dependent on other row. One row can be made using other row. This is not unique. This is not giving me any distinct information what the other row is not providing. Okay, so rank says us that if in a matrix, if one row can be made by other row, so that is not acceptable. So we will say that rank is the maximal number of linearly independent rows. Okay, if I give another example, suppose one matrix contains again 1, 2, 3, and then the second row is suppose 0, 1, 1, and the third row contains 1, 3, 4. Okay, fine. So this is one matrix A. So now I have to check whether these all rows are linearly independent. If these three rows are linearly independent, then we will say that the rank of matrix is 3. Why so? Because each and every rows are linearly independent, are giving me some distinct information, so that is only the rank of that matrix. So this matrix is what? 3 cross 3 matrix. Okay, now I have to check that rows are 3, but whether the rank is also 3 or not, right? If I will make any row with the help of other rows, so that will be called as linearly dependent row, and that is not acceptable to count for the rank. Okay, if you will see this third row, okay, this contains 1, 3, 4. This 1, 3, 4 can be made by row number 1 plus row number 2. That means in this case R3, which is row 3, is actually row 1 plus row 2. right? 1 plus 0, 1, 2 plus 1, 3, and 3 plus 1, 4. Okay. In this case, we will say that rows are 3 for sure, but the rank of the matrix is 2 only. Why? Because this row is actually dependent on other rows. So this is only, we say that why we find the rank of the matrix. Rank says us that how many rows are giving me distinct information, or we'll say that how many rows are linearly independent. Okay. So one important observation is, for a matrix, the rank cannot be larger than the smallest dimension of the matrix. That means what? That means if I'll give you some example of any matrix has 2 rows and 4 columns, this case what we can say, the rank of this particular matrix cannot be larger than 2. The very first matrix what we discussed, this was a 2 cross 3 matrix. So in this matrix, so the rank can be 1, or rank can be 2, but it cannot be 3 or 4 or something, right? Because the smallest dimension of this matrix is 2. In this matrix, this is 3 cross 3 matrix, so the rank cannot be larger than 3. The rank can be 1, rank can be 2, or rank can be 3, but not more than 3. Fine. Fine. So this was the concept of rank, that what is rank and why we want to find the rank of a matrix. Now we are going to see that how to find the rank of the matrix. Okay. So this is the definition, that the rank of a matrix A in its echelon form. Fine. Echelon form last class only we have discussed. So in the echelon form, the rank of a matrix is equal to the number of non-zero rows. Fine. And this is denoted by row A. As per the definition of rank, we have seen that step number 1 is what? We will be converting the matrix into its echelon form. And then step number 2 is what? We are going to count the number of non-zero rows, and the total number of non-zero rows will only be called as row of the matrix or rank of the matrix. Fine. So we are going to first write down this matrix into the echelon form. So for that, my first focus is what? The very first element which is present in my row number 1 and column number 1. And we had said that in my echelon form, so very first non-zero number of non-zero row should be 1. But we can see that here 2 is present. So one thing can come in my mind, that I will just divide this complete row by 2. Okay. But better to avoid this division. If nothing is possible, then only we will go for division. Otherwise, we will do some kind of row transformations, interchange the row if it is possible. So we will just have 1 in this place. We can see that this row has 1 present here. So if we will interchange row number 1 with row number 2, so we don't have to do any kind of division. We will just be interchanging these elements, and then 1 can come in this place. Fine. So what we are doing here, we are going to do interchange row number 1 with row number 2. Okay. So the same thing we have done. Okay. So my next goal is the number which is present at this place. It should be 0. Fine. Remember, we have seen in echelon form that the very first number which is non-zero should be 1, and this is called as leading 1. So all numbers below leading 1 in this column should be 0. Fine, no? So if this is 1, so this number instead of 2 we should have 0 present here. Okay. So how to get 0 here? Okay, so we can have many different operations here, but that should be the elementary row transformation only. Okay. Fine. So don't perform here column transformation. To reach into echelon form, we should do only row transformation, not the column transformation. And I hope that you understand what is row operation, what is column transformation, right? We have seen in the previous class also. Okay, so my goal is to have 0 here. So there are many different things. One thing, you can again interchange these 2 rows, or the other thing is what? You can perform this elementary row operation. That means row 2 is what? In your row 2, you are going to perform this operation, that this is my 1. So if I will multiply 1 with 2, it will become 2. Fine. Then if I will subtract this one with my original row 2, then this place I will get 0. My focus is to have 0 at this place, but whatever operation I am going to perform in this particular row, I have to perform on each and every element present in this row. But I am not worried about what it will become, what it will become, what it will become. I am not worried about. I am only interested in having 0 here. Okay, for that case this row transformation I am performing. So in that case what will happen here, this will become 0, and at this place what will happen here, this will be what, minus 2 into r1, minus 2 into r1. R1 is what, r1 at this place is 2, fine, and then plus r2. R2 is what, minus 1. So plus and minus will become minus actually. So it is what, this is nothing but minus 4 minus 1 will be minus 5. So if it is minus 5 minus 6, I am not worried about. Similarly here also, if I perform this operation, I am going to get minus 9, and here I am going to get 1. Fine. So till here things are exactly fine. That to be in the echelon form, this number is 1. To be in the echelon form, this number is 0. So if I reached here, this number has become 0. My next focus is this place. Okay. My next focus is this place. I should be having 0. Why I should be having 0? Because in my echelon form, we have discussed that each and every element in this column should be 0 below this leading one. Fine. So now I have to think that which row operation I have to perform so that I will get 0 here. Okay. So for that case, what I have done here, R3 is become minus R1 plus R3. And why? Because this is also 1, this is also 1. So if I will subtract this 1 with this 1, then I will get 0. Fine, no? That means minus R1 plus R3. So this is my 1. So minus R1, R1 is having 1. So minus 1 plus this is my 1. So I got 0. So this 0 only I was interested in. But whatever operation I am performing for row 3, I have to perform on each and every element which is present in this particular row. Fine, no? So at this place what will happen? Minus R1 plus R3. So minus R1. At this place this R1 is what? 2. So minus 2, and then plus R3. R3 was having initially 0. So now it has become minus 2. Fine. Now this is what, minus R1 plus R3. Minus R1, that means minus 3, and then plus R3. R3 was having 1. So now this is minus 2. Fine. So whatever I am getting here, I am not worried about. I am just interested in having 0 at this place. Okay, this much also I have got. And then I don't have to do any operation for my row 4, because already row 4 is having 0 at this place. I'm not worried about right now what these elements are, but this is 0. So what I have done, the very first job was to focus on this place. Okay, to focus on very first element which is present in my matrix. This should be 1. If it is not 1, then I'll do some kind of row transformation to get 1 here. Then the second focus is this number. This should be 0. For that I have to do some kind of row transformation. Then the third focus is this number. This should be 0. Fourth focus is this number. This should be 0. This is already 0. So this is the equivalent matrix. Now what is my next goal? I am not worried about what number is present here. Fine. Why? Because in my echelon form, I am only interested in first non-zero entry. That should be 1. And after that, whatever number is coming, I am not worried about. Fine. Now my next goal is actually this number. Okay. Why so? Because this is my first non-zero number of row number 2. So first non-zero number of row number 2 should be 1. Fine, no? So it should be 1. So for that I can do some kind of row transformation with my row number 1 or 2 or 3. But I can see that here 1 is present. So to avoid any calculation, I will just interchange row number 2 with row number 4. Okay. So if I do this interchange row number 2 with row number 4, so in that case even this 0 will be as it is, so I don't have any problem. So what I have done here, I have interchanged row number 2 with row number 4. These two rows I have interchanged. So this is the equivalent matrix. Okay, what is my next focus? My next focus is the number which is present below this one. This one is what? This one is the leading one of row number 2. So leading one is present here. So what my echelon form says, that for any leading number, I should be having zeros present below that leading one. Below that leading one. Okay. Above that, whatever number is present, I am not worried. I am only worried about the number which is present below leading one. So my next focus is this number. Instead of -2, I should be having 0. So can you tell how to get 0 here? I can see that this is my -2, this is +2. If I will add these two numbers, it will be 0. But in that case, what will happen? If I am going to add these two rows, I am going to get 0 here. But simultaneously, I will be getting 1 also here right now, because 1 plus 0 will become 1. So this 1 is not acceptable here. So some other transformation I have to perform. So if I will do something else, and if I will multiply 2 in my row number 2, okay, 2 in my row number 2, then it will become 2, okay, and 2 and then -2 if I will add row number 3. So that means row 2 plus row 3 will give me 0 here, and 2 row 2 plus row 3 will give me 0 only here. So fine, so that I can do. I'm not worried about what I'm going to get here, what I'm going to get here. Even these numbers I'm not worried about, but here it should be 0 0 0, and here it is 0 after performing this operation. Fine, so this much we have done and we have got here. Okay, so once we have done this operation, eventually we have got all zeros here. Okay, fine. So my next focus is which number? Now I have to make this number 0. So how to do this one? So for that, what we have done, we have multiplied 5 in row 2. Okay, 5 in row 2 and then plus row 4. Okay, so then I will be getting 0 here. Okay, 5 into row 2 plus row 4. So I am going to get 0 here, -4 here and -4 here. Okay. Can I say that this is my echelon form? So still this is not in my echelon form. Why? I can see that all zeros are present here, right? And we have discussed that all 0 rows should be at the bottom of the matrix. Fine. So what I have to do? I have to straightforward interchange row number 4 and row number 3, so that the 0 row should be at the bottom. So that we have done. Okay. So that means what we have done. Fine. So that means what has happened here? This is now -4 and this is my -4. This is 0 0. Fine. Row number 3 and row number 4 we have interchanged. Okay. Now, is it my echelon form? Still this is not. Why? Because this and this is okay. But I can see that row number 3, here the very first non-zero number is not 1. The very first non-zero number should be 1. This is my -4. Okay, so my goal is to perform any row operation so that it will become 1. How to make it 1? For that, if we will think of writing down here, this is row 2. No, if I am going to perform 4 into row 2 and then plus row 3. Here it is going to give me 0. Fine, no, 4 into 1 is 4 and then -4 will give you 0. But what about this place? This place will be what? Then it will become your, then here instead of 0 it will become what? It will become 4 plus 0, that is 4, and that is also not allowed right now, because after this leading one below this number I should have 0. So what I have to think, this is also -4, this is also -4. If I will divide -4, okay, if I will divide -4 in the entire row, then what I am going to get? 1 and then 1. Fine. If I am going to get 1 here, then I am okay with. I am not worried about whatever I am going to get here. So to get this 1, I am going to perform the division operation. So after practice, it will become more clear that which operation I have to perform. Focus sequentially on these numbers, then the calculation will be less and then the things will be much more clear. Okay. Now, can I say that this is my echelon form? So yes, this is my echelon form as per the rule. So what next I have to do? So my step number 1 is completed, that I converted the matrix into the echelon form by elementary row transformation. Fine. Here we have not done any column transformation. Okay, fine. So now what is the second step? Second step is once I reach to the echelon form, then I just have to count the total number of rows where the rows have at least one non-zero element. What I have to check, do I have any row where all elements are zero? Yes, the very last row I can see, this row has all zero elements. So that means the matrix actually had one row which was linearly dependent on other rows. And now the row number 1, 2, 3, these three rows are actually unique rows. So they are giving us the distinct information. Okay, so these three rows are linearly independent. That means the row of this matrix is 3. Total 4 rows were there and one row is having all 0 elements. Total 3 non-zero rows are there. And the rank of the matrix is what? I just have to count the non-zero rows in the echelon form of the given matrix. Fine. So here we got that the row of the matrix is 3. So if you find this class useful, please like and subscribe my channel. Thank you.